So for my opening piece, I'm just gonna bring a Bible verse. It's the first. It's in the first page of the Bible, Genesis, and it goes as Genesis 1 to 7 to 9. This is the oldest book that I have in my possession. My family's
Mhm.
obviously had this book for many years. They passed it down, and it's the oldest book that I know that has recorded history in it. And now, being in our time of generation with the technology we have, we're able to prove some of that book. So I'm going to start off with saying, "And God made the firmament and divided the waters which were under the firmament from the waters which were above the firmament. And it was so." So in that statement, I'm just gonna go here and show you a little something. Give me a second. When I look at stars zoomed in, just go here. Well, this is the star of Venus, or the planet of Venus, zoomed in, which mainstream media has given us definitely a different view of Venus. I'm gonna show now. This is what we see that we get to observe. Anybody with the camera can do that. And I can see water reflection there. If you ever been in a swimming pool, you could see that. And we're going to go to mainstream now, and we're just going to show you what they say Venus looks like. So this is what mainstream wants us to believe that Venus is. A spherical object that looks like a planet, I guess you could say. But from many videos, this is what we get. So we can just type in Venus zoomed in P900. And these are many observations from many different people. It's not like it's just one person giving a view, because anybody can do it. And I could definitely see water above. That's a reflection of water. Pretty observable. To close this piece, I just want to show you. If you've ever been on a boat, you know that the water splashes. This was a rocket. Someone got this footage. And to me, it looks like the rocket is skimming the firmament, showing water. It's definitely doesn't look like space. The rocket is protruding with some sort of whatever this is, what you want to call it. I'll wait to see what Alex has to say about it. And then we got this, where they say rockets leave and go into space, but this was shot in a plane above the sky, obviously. You see the rocket going up, but then it turns. And when it turns, it goes right back down. So it's no longer going up into space. It's now done a complete 90-degree angle. And they want us to believe that that is going into orbit, which I do not believe it is going into orbit. If you take a good look at that, you can definitely see it is not going into space.
You're playing.
So
30
that's
seconds.
what I'll start with.
All right, you call time?
Yeah, we can go with Alex on his rebuttal to that.
All right, Alex, your
All
rebuttal.
right. Let me just get my thing set up right here. Okay. All right. So first of all, I'm very glad that our friend here brought up the stars and heavenly bodies as a way to demonstrate the shape of the Earth we're on. If we hadn't, then we'd be able to determine the shape of the Earth based off this method alone. So our friend here mentioned the planet Venus. Now, I don't know where our friend got his sources from, specifically with that video of Venus. I can't verify that that video is Venus at all, but what we can do is we type in planet, if we go to Google and type in planet of Venus zoomed in, you can then see a bunch of images, and if we look at them long enough, we get a general idea. Obviously, some of them aren't going to be, they're just going to be 3D renders. I'm not expecting all of them to be perfect, but you'll be able to see renders of what the planet would actually look like within relative reason. But the main reason why I wanted to bring up the heavenly bodies is because it is the single best way to determine the shape of the Earth with something as simple as the night sky rotation. So in the northern hemisphere, we are able to witness the sky rotating counterclockwise east to west, and then in the southern hemisphere, we witness it rotating clockwise east to west. Now, everywhere we go, we witness it rotating east to west, but how we view it, it is going to be different depending on where we are on Earth. This is a brilliant example of a phenomenon called axial rotation, which only happens with 3D-based objects, like a sphere would. Now, the problem is that when we try to replicate this to a flat plane, when we try to get these three observations to work, we lose one. So in the southern hemisphere, we have it rotating clockwise, as we see right here. And then in the northern hemisphere, it's rotating counterclockwise, but we'll lose the east to west rotation everywhere we go. And then if we try to get the east to west rotation everywhere we go, we then lose the counterclockwise rotation in the northern hemisphere. This is a major hurdle that flat Earth has to get over, and to my knowledge, the only way you can get this to work is by creating some magical explanation as to why it's happening, which contradicts everything that we know and how we observe things ever. The second point that I would like to bring up is that would just shows how crazy flat Earth is circumnavigation of the southern hemisphere. So we have multiple things like flight paths from places like Sydney to Santiago, where their flight paths that make absolutely zero sense if the Earth was flat, because they take great circle routes, and great circle routes only take things that are the closest distance away. Another great example of this is traveling across Antarctica right here. So right here we have multiple paths that travel across Antarctica. And so with the most recent one that I would like to use it being one that was done in 2018 by a gentleman called Colin O'Brady. He would travel 932 miles, which is this pink one right over here. And so with that being said, which is this little pink one, they start right here, down here, over here. This is what that path would look like on flat Earth. He would travel all the way over here and go all the way around this ice edge and then end right over here. So that, according to that is 932 miles. When we have that in comparison to something like the United States, where it's 2,800 miles across from one to the other, it's fair to say that this route is physically impossible to work on flat Earth with the distances and measurements that we know of how they work, because a mile is a mile no matter where we go on Earth. And so no, it makes completely ridiculous sense as to why we would be living on a flat Earth based off the night sky rotation and circumpolar navigation. And as for the comment for why rockets appear to be falling down, that's actually technically what they're supposed to be doing if they're trying to get into orbit of Earth. They're supposed to fall into Earth's orbit so that they can get into a boost. I don't know why he thinks that they wouldn't fall and they just keep going forever, because that's not how they work. But yeah, that is the end of my time. Thank you.
So I'm curious though, Alex. Because I want to kind of stay on one topic before we move to the next real quickly. And the first thing I was talking about was the planet Venus, right? So when you said you don't know the source that I gave, I actually gave multiple sources. Now they're independent research, so that means that multiple people will be taking the video. I'm just going to show you again, just to kind of give you a vast majority of how many people are actually doing it. It's not just one person, it's many people. And what you basically showed us was just Google, which gives us this, right? And that's just a render. To me, that looks pretty 3D. You kind of skip past that without actually providing even a search as to who it was. So like we have people here that are actually doing this footage, and you can actually get the camera for yourself and you can imitate this exact thing. And the problem with what you were saying is that you were just basically going off of what Google showed you and claiming it's true, when that's what these people used to do. And then they realized, I'm going to go do research for myself, and they're coming up with this research. So if you could kindly, before we move on from Venus, let's just talk about your source. And if you could just show us what you think Venus is, so we could all decide if that's real or not, because you kind of just went to Google and showed us a bunch of pictures. I'm actually showing you independent researchers. So I'd like to see what you think is real from that Google search.
Are we doing 5-minute intervals or?
Yep. You got 5 minutes. Go ahead.
All right, perfect. Okay, great. So, actually, and that is a fair assessment right there. And like I said, I didn't discredit that the video was real. All I said was I don't know who is the source. I wasn't saying it wasn't real. So let's get that straight away. But it looks to be like those are people doing it legitimately. Though at the same time, I don't know what the methodology that they're using is. But here's what we can do. Okay, so we can go to pictures of Venus and then we can find an International Space Station or any space agency, to be quite matter, and we can look at all the different pictures of Venus that are available to us, okay? But it looks like it, and so right here, this is a picture of Venus that is from 1974, February 5th. This looks kind of familiar to what we have, but at a much higher resolution, and to what our friend here showed, so I don't see why showing a picture of Venus would indicate that the Earth is flat right there. And you have multiple different pictures of Venus right there. So here's one right here. This was from February 5th of 1979. This one is from, oh, this one does not have a date, which that really should. I probably could find it later. This one right here is from October 13th in 1994. Seems to be a pretty clear image from the Magellan spacecraft from NASA. So I really don't know why we're being objective towards planet Venus. Furthermore, I find it interesting that my friend here did not even attempt to address my arguments related to the celestial bodies, which I find very interesting, because I don't see how Venus, and being able to see where Venus is when a space agency tells us where it is, proves that the Earth is flat. If anything, that would solidify that the Earth is a sphere. Yep, and that's the end of my time.
Sure. So basically what you're saying is all the information and photos you just shown are from NASA, correct?
Yes, some of them are. Yeah, but from different time frames.
So how could I take that for seriousness when we have them in space with blatant green screens, just like as seen right now? You could see on the globe there's a blatant green screen because there's text in the globe, the little face here. So how can we trust those pictures when we've known to see deception from these people? Could you elaborate more? Because as far as I'm concerned, all the images you got were from NASA.
Sure. So yeah, so I don't see I don't see any green screen effects. What appears to be happening right there is that there is an overlay effect in whatever studio program that they're using, and it's overlaying that with the text. If anything, that would show that it's actually they're not using a green screen and they're just chroma keying out. That's it. That's
Well, the thing is that's kind of how a green screen works, right? You see how that globe has green and blue on it, so it's causing a glitch effect.
Yeah, but have you ever used a chroma key effect before in a video program?
That's not what I'm stating. I'm stating that NASA has deception. There's proven deception. I could show you more deception from them. That's just the most recent deception, right?
Yeah, but the problem is that that's not an actual deception. That is an editing error on their end. So when you're making a program,
why didn't they acknowledge it then?
Why are you interrupting me?
Oh, hold on, guys. Let's not interrupt.
Okay, thank you. And so when it comes to actual video editing software, you can have the ability to chroma key things out even though you're not actually using a green screen. So you could have someone wearing a green hoodie, for example, and then you can chroma key the color green and then put whatever you want on the color green, and it will show up on their hoodie. That doesn't necessarily mean they're using a green screen right there. That means that in their video software they use a chroma key. That's it. So an actual green screen effect would not have the ball home spin like that and then have the letters pop in the way that they do. So if you're familiar with chroma keying and how that works, which I could probably do right now actually, if we have the ability to in real time. Yes, I do. Yeah, we can do that in real time right now actually, if we'd like. But at the end of the day, I don't see how that is an error. And if anything, it's just a deflection to get away from the point that we have high quality pictures of these things, and you're just showing to some other thing that is a video error. That's it.
Right. So just to be clear, all the photos that you were showing were from NASA, your space Venus.
No, Xfinity. Hang tight, guys.
Okay.
So you still have your time allotted to you, Alex. If you want to concede it, then go ahead and give it up to Xfinity. It's 5 minutes per.
I'm conceding it right now. It's just that he was asking me questions. I thought it was just that kind of back and forth going on.
Xfinity, be careful on your questions because once you ask it and he answer it, he has 5 minutes. He'll take your time. So be careful on that.
Yeah, because I want to be fair with that as well.
Right.
All right.
Ahead,
so
guys.
the next piece I'm going to go at is basically he mentioned the star trails. He started talking about it can't work on a flat Earth because they're both rotating in a different direction, and that's just a perception issue. So the thing is, when you look at the stars based off of a compass's standpoint, they always go from east to west. Now, when you have this dome-like effect, that's what the firmament is. That's what's described by in the Bible. There's many videos just like this that show you from your perception that it's actually going to appear to rotate in a different way, just depending on where you are as for perception. This is a video that's not hard to find. I mean, many people can go and take a look for themselves. I mean, I've only looked at a few of them to realize, like, you know what, this is definitely what it is. It's just a perception issue. It will actually appear to go a different way when in fact it is still just going east to west. So he said that it would be impossible on a flat Earth, but there's actually demonstrations online that you could go from independent verified researchers that have proven the star rotations to go in a different route. And as for the stars, since we're still talking about the sky, we got Mars here. This was a footage taken from NASA. Again, more deception from NASA. The ones that he's claiming his planet view are correct. And we see here when they shot this footage of Mars, but over here in Canada, we have a place called Devon Island right near Nova Scotia, and it's the exact same place. So how can we believe these people when they're claiming something is Mars, but then we have the exact same spot right here on Devon Island? Independent researcher got this photo and shows that, you know what, it's actually wrong. They're lying to you. So I just wanted to be clear about the person that you're getting your information from, NASA, probably isn't the truest when they've been shown to give deception between green screens, between faking planet walks, like they're on Mars. There's all sorts, but I'd just like to hear what he has to say about the star rotation and what I just basically showed him there.
Okay, yes, thank you. I will gladly talk about the star rotation. So right here, I have a demonstration of it. Was kind of similar to what he showed, actually, though it's a different, a more newer version, I guess. So right here, we have an example of all the stars rotating east to west. Here is the problem. We need this star rotation right here to rotate clockwise one way, have them all go east to west, and have them go counterclockwise all at the same time simultaneously of one another. That is something that we need to happen objectively. And in this example right here, it clearly shows that it's impossible to get this to rotate the other way. And we can even demonstrate this further with the example that he gave us of a personal dome of the firmament. And so right here, I have a personal view of what the person would see. Let me just adjust my camera a little bit. There we go. A personal view of what the person would actually see versus what the claimed effect is happening. And so we can even go into first person right here. So
Alex, just to be clear, I just want to ask you a question. Sorry to interrupt, but just to be clear,
yeah, that's fine.
At the equator, do the stars rotate clockwise, counterclockwise, or do they?
Xfinity.
Yeah.
Xfinity. We're not doing that. Like, no, we're not doing that. Like, you're hurting yourself. No cutting off, man. He has this whole time to speak his. Hold yourself and clip it up and ask him where you're going.
I would like my
Appreciate it.
time. I would like to reclaim my time with that as well.
Yeah,
But yeah, so
sure.
I will answer his
Reclaim.
question. I will answer his question though. So at the equator, they rotate overhead east to west. That's not even, that is. I'm not going to disagree with that. That would happen in both models. But here's the thing that you have to get it right. Okay, this is looking directly towards south. Okay, so towards the southern hemisphere. This star rotation is rotating clockwise east to west. Okay. Now here's the problem. I'm going to disable what is actually going to be happening, okay? This star ranked rotation claims that it's actually rotating in counterclockwise east to west. So the question that you need to answer when it comes down to this phenomena is why, if you're going to claim that there is some sort of firmament, why is it that the firmament is causing us to see one thing when it's actually doing a completely different thing? I don't see how the slapping of a firmament over it is going to help. And to even further cement home that this idea of the firmament not being a real thing, they attempted to look for a thing called the luminiferous ether in the Michelson-Morley experiment, and every single time they tried to search for the luminiferous ether, they've never been able to find the results for it ever. So, and with that, I would like to end with that.
So I'll give you some of my time because I'm not sure what you just showed us is basically a pizza disc, and on top of it, a pizza disc of stars all rotating in one direction. But observably in our planet at the equator, the stars are actually just moving in a line, which is actually shown in the video I had with actual evidence. And what you basically said is they're just all spinning in a circle, but we don't actually experience that in the world that we live in, because people that live at the equator, they actually see the stars just like this. So how would that work on your globe if they're going straight, but in your defense, you think it's just all going in one circular motion? At the equator, they just go straight like this. There's no actual circle. So the only circles are when you go in the southern hemisphere and in the northern hemisphere, which is described right here. There's many videos of it, but as you go further away from the dome, it appears to rotate in a different way just because of the perception. And I just wanted to add that the people in the north see a different stars than the people in the south. We don't actually get to see all the stars on our topographical plane. It's actually divided into two from the equator. So how would that model that you just showed us, all going in one circle, describe the equator?
So you're absolutely right. This is not what we observe in reality, because this is because the Earth isn't flat. So the reason why we are able to observe that phenomena is because when we replicate this phenomena on something like such as a sphere, it works perfectly well seamlessly. Okay. So if we go to this example right over here, where is it? We scroll. Yep, this is the one right over here. We're gonna go over to the right. So when we roll a sphere, okay, and this is an example of it right here. When we roll the sphere, one half of it is going to be rotating counterclockwise, while the other half is going to be rotating clockwise. This is not a new phenomenon. This is what we call axial rotation. Okay, and so right here we have the example that it demonstrated in a different way, where I have three people looking up at the night sky, and they're all seeing the same exact rotation no matter where they are. So those things don't magically change depending on where you are, simply just because you're looking at it from a different area. That's not how rotation works. The only way that these people are able to see the rotation from a different point of view is if they were on the other side of this little disc right up here, okay? So hold on. So the argument that you're going to have to make is to explain why is it that we are able to get on the other side of the stars in order to view them rotating a completely different direction. That is the only way that you're going to be able to do this. And by the way, you didn't address my argument about the luminiferous ether or the dome being not unobserved in any way, shape, or form during the Nicholson-Morley experiments. And with that, I'm done.
So the only thing is, what I've showed you is actual demonstrations of how the stars would rotate. and you just showed me a Microsoft Paint version of what you think is happening, but could you actually show a demonstration of the stars actually spinning in a different direction being underneath the equator? Because that's right now you've only shown a pizza disc of stars and you haven't actually shown us how the stars actually spin. So the actual model is what I'm looking for from you, not just Microsoft Paint. Do you have a model?
Oh yeah, I can show you how it works. Okay, so just give me 1 second. Okay, so let me just get my program set up. Okay, so right here, this is not intended for this, but it's okay. This will work. So see right here. So we have a sphere right here. I'm spinning it this way right here. See, and then at the top right here, I have this ray spinning clockwise, and it's going east to west. So if we were to look up, this would be spinning counterclockwise. At the equator, it's spinning clockwise, meaning that they would see the stars going overhead. And then on the bottom, I have it rotating counterclockwise, which for the people on the bottom, they would see it going clockwise, east to west. So I really don't know why this concept of east to west rotation changes simply based on where we look. And again, I would like for you to show us a demonstration of the dome actually being an actual thing, because again, I showed you multiple times they did not observe it.
So again, you just spun a ball and you claimed that to be how the stars spin, but you didn't actually show us how the stars spins. You can clearly see right here that they start to spin outwards as described in the equator. So the thing is, we need to see why the equator, the stars are spinning a different direction. Like it shows here with a firmament, how it would easily start spinning the other way. Do you notice how they're curving the other way now as you go out? And do you notice how the equator, they go straight? It's just a perception thing that I think you're missing.
Okay, I would like for you to demonstrate that actual thing happening though. So right here, I have this night sky rotation. This right here is in the northern hemisphere, around the equator line. So I believe right up here, looking to the east, rising. So this is what it looks like to the east. This right here is looking towards the northern hemisphere. They're right over there is Polaris, but they're going counterclockwise right there. And then right here, we have it rotating clockwise, looking directly towards the south. Yep, no problems right there. So again, this is the direct result of the sphere, because when we rotate it this way, when we look towards the north, okay, north is this way, and I spin it east to west, it's going counterclockwise. When we look towards the south and we spin the ball east to west, it is rotating clockwise, just like we observe. So I don't know what the point is that you're not getting. If me showing a cartoon ball is the problem for you, then I could easily say the same, that those lines on the screen in that little magnifying glass you have is equally as invalid. Because I understand the concept that you're trying to say. All I'm trying to say is that, can you show us that the dome is actually a thing? Because I showed you how it works with a sphere. One side spins one way, one side spins the other way, even though it's both spinning in the same way. You need to show me the evidence of the dome.
This model right here, right, is spinning anti-clockwise in the northern area. Do you see that? And as it goes to the equator, it goes east to west. And then when it goes to the southern, it goes east to west. Will you agree that you see this experience?
Yeah, the observations that we see are not in question, okay? Is that a fair thing to say?
So will you agree that as this ball comes further south, the rotation appears to be going in a different direction? Will you agree?
Yeah, when we look towards the southern hemisphere, it rotates different from the north, yes.
And from this experiment, the person's perception is going to see it going the way that it's as shown, as you see up here. Same for this dome. Will you agree?
I would agree, but I would change the verbiage of what you're saying. That person is actually seeing it. They don't perceive it to see it that way. So if we get another person down there to verify what this person is seeing, they're going to see the same exact thing that they are going to see from a completely different area of the world.
Perfect. So I just need you to agree to that. So the next thing you went to was flight paths. And I'm happy you brought that up because let me just go right here. So we're going to take a look at some flights and we're going to look on a flat Earth standpoint, these emergency landings or even the check stops and just understand how it works on a flat Earth and how it wouldn't work on a globe. So I'm going to start off here. I'll give it some volume maybe.
So here we have Auckland, New Zealand.
We're going to
Buenos
Auckland
Aires, Argentina.
to Argentina.
Search. Okay.
He's looking for a flight.
2 stops. All right. So we go from Auckland to Los Angeles. What? And then from Los Angeles to Houston, and then Houston to Buenos Aires. Like, am I the only one that finds that weird? If we live on a supposed globe, honestly, that seems like a waste of gas. So we go from New Zealand to Los Angeles, then to Texas, then back down to Argentina, and needing to pass the equator. Okay, guys, just hear me out real quick. So let's just see what the flat Earth map depicts. All right, so you guys have to see this. So we go from Auckland, New Zealand to Los Angeles, then to Houston, then to Argentina.
Notice how on the flat Earth map, we'll just pause it there at just that specific flight. So it literally went in a straight line using the flat Earth map, but in the globe, it would go above the equator, go north, and then come back down south. Can you explain that?
Sure. So if we want to switch to the topic of airplane paths, we absolutely can. But I would like for you to concede that you actually didn't explain the observation of the dome in any way, shape, or form with the night sky rotation.
Of course I did. I showed
you
you
didn't.
exactly what happened. Yes, you conceded, brother. You agreed.
No, you
that-
didn't. You just
you
asserted that there
agreed-
was a dome.
No, you agreed that the star rotation, as shown, would work from that observation. You agreed. So I thought we were done.
That's not conceding to a dome. That's conceding that the observation is observed in that area the way that we see it. You need to establish that there was a dome in that area.
Well, there is. That's what the firmament is.
Okay, where
From
is
my
it?
opening statement, I showed you on Genesis, the oldest book, there is a firmament, and then I showed you stars with reflecting water, and we could even go further and show even more stars, but we didn't even have to go there because I went into the rotation, but you could see all sorts of
Yeah, the Nicholson-Morley experiment, though, demonstrated that there was no observed firmament or ether which you're talking about.
But the thing is, experiments you're talking about are 100 years old, brother. What I'm showing you is footage taken in the past 5 years showing water reflection.
Yeah, the reason why no one's redid this experiment is because every single time they've attempted to replicate and detect luminiferous ether results is that they came out flat every single time. And so they gave up on the luminiferous ether idea of there being a firmament and to establish different ways of measuring of why there's pressure within our atmosphere. So again, you need to demonstrate that there is a thing rather than just showing some blurry video on YouTube or TikTok or whatever the platform is. Because we can't just assert things the way that we want them to.
This is water. This is stars. All appearing to do the same thing.
I don't know that.
No, you don't, but that's why I'm showing you.
Yeah, I don't know that those are stars in that right video that you showed.
But is it safe to say that if you had one of these cameras, you could observe this for yourself?
What camera? Yeah, I don't know what the thing that you're showing is. You could have just barely gotten that from someone who could be lying to you.
So all these stars, okay, I'm going to explain to you, Alex, are stars shot with a P900 camera, okay? And I want to explain something very clear to you.
Why so small?
What's so small?
The P900. Why are we using the P900 for that?
Well, I'm going to get to that, but is it safe to say? Is it safe to say, Alex, that this is light reflecting through water when I show you this?
Yeah, the one on the left is light reflecting through water, but why would that mean that it's the same for the one on the right?
Hold on. Now, is it safe to say that looks like water too?
No, I mean, just because
that is water.
How do you know that it's water?
Because that's hold on. That's the cup, right? And that's the water, right? Will you agree that looks like water reflecting light? Because that's a cup of water.
I mean, it looks more like it's electrified than it is water. But like, if I was looking at it for a first glance, I would say yes. But just because it looks like something doesn't mean that it actually is.
Okay, and now is it safe to say that that right there kind of looks the same, even though it's blurry?
No, those things don't look the same at all.
They don't.
The way that they're formatting and not formatted, the way that those things are forming are completely different from one another. And not to mention,
Okay,
you
so
need
now-
to show that those things are water but translucent, being an in between space. You're not doing that. You're just showing that.
I'm gonna show you something.
Start now.
Just out of curiosity, though, while you're looking that up, where are you getting your sources for your stars that you're seeing?
Okay, so is it safe to say I'm showing you that right now? I'm happy you brought that up. So is it safe to say that when I type in Nikon discontinued, that we get a date of March 1st, 2024? If you look at when they discontinued this camera, and this is the digital camera world, so they can show you, but it's Nikon is axing its most outrageous and impressive camera. Can you tell me that date? Right there?
Yeah, that says March 1st, 2024.
Okay, perfect. Now I'm going to show you something else. Because you brought up a lot of NASA, right? And so
Yeah, just so on the same page of this, it's the Nikon Coolpix P900 that you're referring to.
can you tell me, before I tell you what that statement is, can you tell me what that date is?
Yeah, February 29th, 2024.
So is it safe to say that this article was 3 days or 4 days before that other article?
Yes, they are, but what do they have to do with one another?
Well, that's what I'm getting to. So basically, March 4th, 2024 or March 1st?
I believe it's early March, we'll just say, because
Perfect. Okay, so they discontinued their camera, right? Now, this is NASA. This is who you rely all your information on. And 2 days before they discontinued their camera, NASA signs agreement with Nikon. So this is the company that built the camera that is showing you all that beautiful imagery from space. And now this is NASA, the great deceptors, signing an agreement with them days before the discontinuation. Why don't you find that oddly relevant that days before they discontinued their hottest selling camera, they actually signed an agreement with NASA?
No, I don't find that odd at all, because just because one company does one thing with NASA doesn't mean that they're connected to each other in any way, shape, or form. You need to establish that there's a connection between the two rather than just asserting that there is one.
But
So
you were
this is-
asking,
No,
you were asking where we were getting this beautiful imagery, and I showed you where they're getting it. But it's a discontinued camera now, right?
Yeah, why would
so
you-
you can't buy this camera from Nikon. You'd have to buy it secondhand from someone now.
yeah. Why would you use a P900 to shoot a picture of a star?
Well, if you look at my images, I don't think I've ever seen a star so beautiful. Like, I mean, all these images,
Yeah,
it doesn't even.
There
it
are
doesn't
better
even,
images of stars out there.
No, there's no comparison, brother.
What do you
there's
mean
no
there's no
comparison?
comparison?
Do you see that? Look at how different these stars look.
Yeah, yeah. Now,
Why would they
what
look
stars
so
are
different?
those? What stars are those?
I'm asking you.
I don't know. 'Cause, I don't
this
know.
is all real footage, right?
I don't know that.
But like I said, if you bought the camera, you could falsify these for yourself, and you're going to be a shock to see what you see.
But again, the thing is that I don't know what stars these are. I can't verify that these are shot with a P900 in any way, shape, or form. Like I said, you need to find the
Oh,
connection between.
you want to see?
Why are you interrupting
want
me?
to see it? You want to see it right up front, right?
No,
So you
I
want to
would-
see something like this?
No, I want to see something where it is a 100% clear, crystal clear footage thing of a star, and you're saying this is shot with a P900. Those things are incredibly blurry. There's no way to verify that that was shot with the proper equipment. And I don't doubt that's what actually happened with the P900 that you're showing. The thing is that you need to provide the connection between the two. You're not doing that. You're just asserting that there is.
I can pull up that footage.
You're doing the same thing you did with the firmament dome. You're just asserting that it's there with no evidence.
Does that look
20
like it's shot
minutes.
with the camera?
It is, but at the same
Okay.
time,
Just making sure that you see the
What star-
actual raw footage.
what star is that? Do you know? What star is that, by the way? Can you tell me?
Is it shot with a camera? Is that shot with the camera?
Yeah, we are agreeing that it's shot with a camera. Now tell me, can you,
All
or at
right.
least can you tell me, what star is he trying to look at?
Now, does it look like a ball that you can land on? That's what I'm asking you.
The question was, what star is he looking at with that?
That's supposed to be a planet.
Okay, which planet is that?
It doesn't matter which planet it is. Can you land on that? Does that look like something you can land on, or does it look like a luminary?
I don't know if that's a planet or not, if you can't tell me which one it is. I don't know what that is for a minute. It could be something that he's doing right now just to make it seem like it looks like a planet.
But that's what I'm saying, Alex. So, given this footage, when you zoom in with the camera that NASA had discontinued days before they signed an agreement,
Hold on.
this shows water reflection.
Hold on. Stop right there. Prove that NASA discontinued it.
How much proof do you need? I just showed you.
Yeah, you
NASA signed an agreement. What's the date?
Yeah, you showed a NASA signing an agreement with Nikon to make sure that way they can use Nikon's
Okay,
cameras for their
and now
stuff.
what does this say?
That yeah, Nikon discontinuing a camera and Nikon
But
making a
you
deal with
don't think
NASA
that that's
are not connected
relevant?
with one another. No, they're not. Should you need to
It
see?
was in the same week.
So here's what you would have to look for, okay? You need to look for an article that says NASA asks Nikon to discontinue P900. You didn't find anything like that. You just said you found an article that said P900 discontinued, and then another one that said NASA
Dude,
teams up with.
look at the article. It was a day after.
Okay, does
It was
NASA the
literally
culprit of
one
that?
day after.
Yeah, let's read the article. Let's keyword search NASA.
Unique, trailblazing, yet arguably unnecessary. This is my eulogy to a camera that was a legend right from its launch. So they axed the camera that was one of the best cameras they've made. You could read the article for yourself, but they axed it the day after they signed with NASA. And
Again,
this thing zoomed in
okay.
right to the moon, man.
Again, keyword search that article for NASA discontinuing it. You're not doing that. I can do it for you if you'd like.
Do you know what the definition of deception is?
Why are we diverting away to definition?
Because do you know what the word deception is?
Why are we diverting away to the word deception?
Because you're asking me to find NASA in an article when they're being deceptive. Why would they put their footprint in that?
They didn't put their footprint in that. You need to show that there was evidence of that. All you did was that, oh, NASA made a deal with Nikon. And then days later, Nikon discontinues the P900.
I'll help you out. Deception is the act of deliberately misleading others by providing false information, hiding the truth, or withholding facts. If they have a camera that's so easily accessible to people that can show proof of a firmament, I think it would be highly deceptive for them to have it discontinued days before. So let's just say that Nikon was spending, they were making $10 million a month off of the Nikon. NASA could have easily walked into their office and say, listen, we see that you're making about 10 million a month off this camera. We're making about, 70 million a day. So what we're going to do is we're going to start paying you 15 million a month to discontinue the camera. So you get better sales, but you don't have to sell the camera. That's what deception is.
Okay, so I actually found the article that you brought up thus far. It says,
Sure.
It's Nikon is axing its most outrageous and impressive camera of recent times. So this is the one that you brought up, March 1st, 2024. When you keyword search the word NASA in it, and I can show this right here, it shows a result of 0, 0, meaning that there is no result on NASA related to this argument, meaning that NASA did not count it, can it? And if you do a little bit more research, you could actually find out that Nikon actually made a successor to the P900 called the P950. And if you actually look at the release date, which we can go to its Wikipedia page right here. Okay, it's right here. which is nearly identical to the P900, adding several improvements. Most notable being a flash or hot shoot, 4K video, and raw shooting. So if you wanted the answer for your question, yeah, this is the reason why, because they have a better camera that does everything that this one does, but better and at 4K resolution. So maybe instead of actually looking for excuses to connect it to NASA, you could actually take a look at what the company is doing independently of it, rather than just making blind assertions.
So, with Nikon a day before they discontinued the camera, yes or no? Will you agree to that?
Yeah, we can agree to that, but those two things are not connected to one another.
So, I just want to hear. Will you agree that NASA signed with Nikon a day before they discontinued their best camera up to date? Yes or no?
Yeah, of course I'm going to agree to that, because that is what's
Okay.
actually documented. But those two
And
things
will
have
you
nothing to do
agree?
with one another.
Okay, no, I just needed your agreement. So will you also agree that most of NASA's information, you take it for face value and believe it? Yes or no?
It's not that I take it from face value and believe it. It's more of that I take a look at it once they present something, and I go over the literature that they bring forth, because all of NASA's documents are available for you to look at, like completely for free. They don't hide it from you. So like you can go ahead and go to NASA right now, or not just NASA, any other space agency in the world, and you'll be able to find the information that you want related to this.
So
like
do
if
you
it-
trust NASA? Yes or no?
Yeah, of course. I don't want to see why not.
Okay, so then it's safe to say that right now you're having a biased opinion as to the disagreement that I have that they signed with Nikon a day before, but I just thought that the relevant information was needed to be said as it pertains to the camera being discontinued. So that's just my statement, right?
The camera being discontinued and them making a partnership with NASA have nothing to do with one another.
But
You need to
that's from
establish the
your
connection.
standpoint. That's your standpoint, and
Okay.
you
What
trust
evidence
NASA.
do you have? What evidence do you have to suggest otherwise?
The evidence is that they no longer will sell the camera.
Yeah, because they have another camera called the P950, which is a better version of the P900.
They actually have a P1000 better, but actually, if you look into the specs of those cameras,
That even further cements the point.
they don't do as good of a job as the P900 if you actually look into it.
Yeah, we can actually look into the specs. Is the P1000 better than the P900? Let's see. Yes, the Nikon Coolpix P1000 is significantly better than the P900. It offers a vastly superior zoom range, reaching an equivalent to 3,000 millimeter equivalent versus 2,000 millimeter equivalent. So it's able to see much farther compared to the P900. And keep in mind, this is the one that you brought up. This version is better. Is this one still available to look at and buy?
The P1000?
Yes.
I'm not too sure. Not at the camera stores in my province. But you could buy them online.
Oh, there's a P1100 out that you can buy. So there's even a better version of the P1000. So like it just seems like the reason why Nikon is discontinuing these older cameras is because they have better versions that are going to do what the previous one did, but way better. So instead of trying to make some assertion that they're discontinuing it because NASA telling them to, it's simply just because their shelf life is over and they have better cameras that do these things way better. That's it. And if you believe that there is, you need to do some hard research. You need to do some hard research that shows that NASA is the reason why these cameras are being discontinued, which you haven't done. You're just making assertions.
Time start. 11 minutes.
So now what I'll say, since we're still talking about the sky, I got this video here. It's just loading up. So this is another independent researcher shooting his camera up into the sky. I'm not going to go too far into it because, as you can see, it's 2 hours and 57 seconds long, 57 minutes. But we're just gonna get into space here, okay? So in the video, before I show you this video though, from your standpoint and science, at what point, at how high should you be able to see curvature?
I'm not sure. So when I make arguments related towards the shape of the Earth, I don't go over its curvature rate because I recognize that you don't need to know the Earth's curvature rate to know that it's a sphere.
Okay, well, your NASA, right? NASA and the Earth Science Stack, they assert that at about 50,000 feet, you should be able to see it. But they also say at 1,000 feet, it will be very permanent. Is that correct? That they say that at about 100,000 feet, you should definitely be able to see it?
Well,
Because that's what science says.
Well, I hope you know that if you are going to bring up curvature rate and that you don't see it at the rate that you're claiming that you do, you are by then saying that the curvature rate is different, meaning that the Earth is still a sphere if you do this, right?
No, but what I'm going to show you is zero curvature. Zero curvature.
Okay.
So this is an independent researcher.
Let's give them a second. Like, you got internet issues.
Yeah, okay. Yeah, I was going to say something, but
I'll be gone for a second. Liking this battle so far in the chat, put a 1 down there for us, please, if you're liking it so far.
okay, so
We got a
I
few
can
more.
pull up
few
that
more.
video right now
Yeah.
that he had. So it looked like
Go right there,
weather
that big screen.
balloon footage right there. High altitude. I'm gonna try to find
Is
this.
Chris Williams in the chat? Is Chris Williams in the chat? Your battle was up next. Are you in the chat?
Oh, did he leave? Up, yep, found the same exact one that we have. And I'm gonna try to get to the same exact one that he was at, so that way we're fair.
Yeah, I think his internet probably went out because it's been out.
Yeah, I'm that, or like his phone battery died, or something like that.
Could be.
Okay,
Yeah,
so here's
could
what
be.
we can do to test this one claim right here.
All right, so
Now,
his claim is that it's flat. Is that correct?
yeah, he's claiming that this is flat. So in order to test this,
Okay.
actually, what we can do is we can screenshot it right here, and it does look kind of flat, though I will admit, but this is going to be the ultimate helmet test right here. So we're going to go into Paint right here. Oh my God, the rendering of this is going to be so bad. Yeah, I see curvature too, Michael, but okay, so we place it in here. Just give it some time to load. Okay, there it is. Okay, we can see curvature right there. So all we have to do is take one line right here and then start from right here and then try to keep it as straight as possible. And oh no, look at that. It's definitely curving. And if we zoom in, right here, so we start right here towards the horizon and go along with it. Look, it's curving away. Look at that. So he showed footage of it curving away. So I think that should be the end of that. Do not save that. There we go. That was pretty simple. And that's what
Okay,
he
so
showed, by the
we
way.
have 6 more. I gotcha. Okay. Only thing with that is he's not here to really go into it. To give his description of that. So let's give him. I mean, still have 6 minutes. We can give him at least half of that to come back in. If not, then we can concede this battle. Then we'll go to the judges, and we get their critique.
Yeah, I'm just.
Get their critique.
Yeah, that's fine. Like, we can have a small Q&A.
Yeah, definitely gonna have one. I just want to give him some time to come back up because it seemed like he lost internet or phone could have died and he could. I don't know. Like, I have no idea.
Yeah, I'm fine with giving him the ability to look.
Yeah, I don't even see him in here. Yeah, let's give him some time to come back up. In the meantime, excuse me. In the meantime, judges, can you guys please request up? You judges, please. Judges, please request up. All of the judges, please. All right, Hassel, Judge, and Lady a Judge, and who else was the judge?
Kinematic.
Right.
Who was it? Oh, man.
Kinematic was the judge.
Okay,
Right.
right here. Is that right? Yeah, Matic? Yeah.
Question, by the way,
I'm gonna have to go full
Kinematic,
speed
have
down
you
the hill, though,
experienced
and I'm
Lady
still
Jessica
worried
yet?
I might not make it. And if I do make it,
That's a
it's
lot of
not gonna
time.
survive it. We might just
Who
give
was
someone
the
a bonus
judge?
point if they make it
Who
to
am
the
I missing?
last jump at this
What?
point.
Mac,
There you go.
Mac, you got to mute,
You
dude.
get a bonus point if you make it to the end. And then if you go
For what?
over,
Somebody got to mute. Somebody got to mute. Somebody got to mute.
Hello,
Somebody got to mute.
Mac, your
Somebody got to go.
Mac, your background noise is nuts, man.
Yeah, it's crazy. It's crazy. All right, so let's go ahead and concede the battle. I thought that was a good battle. What you all think about it? Like, was that good? You're welcome to speak. It's
Yeah.
open. It's open.
Can't-
Oh, actually, hold on. Hold on. Hold on. Hang tight. He's back. He's back. He's back. He's back. He's back. He's back. All right.
Yo, my
Judges
bad.
go
My
on mute.
phone died. I thought I had a bit more percent there. I'm sorry.
We figured. Judges, go on mute for a second, please. All right, Infinity, I give it back to you on your description of what you were doing. You guys, it's
Yeah.
9:20 right now. The battle's over at 9:23. If you guys need an extra 2 minutes, we can give that to you. If you guys
I just
need
wanted to show the observation of the flat horizon, zero curvature. And this is many different observations from many different people. I'm just going to start on this one here. As you could see, 120,000 feet up in the air, there's zero curve. It's actually gonna spin all the way around.
I don't know how to tell you this, Infinity, but I don't think you were here when I showed you this, but when I took a screenshot of that video that you showed, it's the same exact one. I can show you my YouTube search results if you don't believe me, but this is me dragging a line across it from one horizon to the other, and now if the horizon is flat,
Could you let me finish, sir?
you paused.
And then, no, I know my phone died, but could you just let me finish and then I can let you go over what you're gonna do?
Yeah, sure.
Okay, so as you can see in this video, it's a flat horizon. I just want to mention that the camera isn't completely straight. It's actually going like this because it's on a balloon. So it's actually tilting a little bit this way. It's tilting a little bit that way. And then, so that's the first video showing a flat horizon, zero curvature, which in science, they state, I don't know why my camera's getting all blurry. Okay. In science, they say you should definitely be able to observe it. Here's another angle of another video showing complete flat horizon. There's zero curvature there. I'm just going to let it play for a little bit. So as you could tell, they're in space. They're higher above than any plane is. And you can see it's a flat horizon. There's zero curvature there. So what I want to mention too before I finish on this flat horizon where you could see zero, when you're taking a screenshot of something when it's tilted, you could use straight lines, but you could also make a untrue statement in what you're stating because there's zero curve. Everybody can go to this video for themselves and then they can see that there's actually zero curve. But yeah, I'll just finish there. You can go on.
Okay, okay, thank you. So what I did in order to prevent that from happening is that I paused the video so that way I get a clear shot of the actual video frames it because you're saying that it's flat, right? So if it's flat, we should be able to see here a straight line go across it and be parallel to it. Lo and behold, it's not parallel to it. So if we go right here, okay? So we see right here at the bottom, right here, not there, it starts parallel. And then as we scroll up with it, oh look, it starts to divert away a little bit. And lo and behold, it continues to divert away until it goes, and it no longer is parallel with one another. So with how we know things to work with spheres, that it's only parallel to something only after a certain point. So if you want the line to continue going, you have to wrap the line around the ball to continue to be parallel, following it. So
Alex, you realize that the horizon you're looking at is tilted right now, right?
yeah, tilting the camera itself doesn't change how
Do
the things operate.
you want to do a screenshot of this one and show us that? Because this is flat and it's not moving as much.
Why is
You
that?
can do your same-
Is that one better than the one you just gave me right now?
Well, it's just not moving left to right as much as the one you're looking at. But from what
It's
you're
a
looking
still
at,
frame.
still it's flat.
It's a still
Just so
frame.
you know.
This one that I'm looking at shows that it's curving.
There's zero curve in what you're showing. But I'm just
No, this right here is a straight line that's going across from one side of the horizon to the other. It's clearly showing that it's not that it's curving. So which is it? Is that video better, or is this one more is equally sound?
They're both flat, Alex.
This says otherwise. This shows that it's not.
You're just observing it incorrectly. That's all.
How would you like me to observe it? Because this is a direct
I have
screenshot
it
from
on
the
a
video.
I have it on a still shot for you if you want to take a screenshot and do that same little petty experiment you did. But
I mean,
do you want to?
I mean,
Do you want to take the screenshot?
if looking at something to see if there's curvature is petty, then
What
I
you're
don't know
looking,
what
you're
a
looking
petty
at
is.
right now, it's zoomed in light, and
Yeah,
you're not proving.
Yeah,
anything,
and
just so you
I
know.
can have it zoomed out, and guess what? Look, you can still notice that it's curving away. Yeah, even if when you
No.
zoom out, you can still see that it's curving away.
The camera is like this right now. Do you realize that? So it's going with your camera. Your line is going with your
So-
camera.
Time.